This is a tutorial for the magnetism simulation for my website, which is right here. And when you load it in, you can grab magnets. You actually can grab all these things from the side here, but you can grab a magnet here, and if you click in the center, you can drag it around, and if you click on the, you can rotate it around. And one of the first things I might do is you can drag compasses, and they will, of course, point in the correct directions according to the magnetic field lines. You can also, if you just drag the compasses over here with a red circle, it gets rid of them. You can also put on field, and it shows the magnetic field lines, I guess, as triangles. You can drag them around and rotate them. You can even use a frequency and have it rotate. So that's the bar magnet. The coil operates in pretty much the same way. It just looks a little bit different, and you can increase the current, and it will increase the size of the field. Although it doesn't change how fast they go downwards, I should probably adjust that. But if you use the right-hand rule on this coil, you will get a north pole on the right side. And you can also bring your compasses out. If you find the field too distracting, you can always get rid of the field. Getting rid of that. You can also get a wire here. And we'll put on the field here. You can see from the dot the wire is coming straight out of the screen at us. And if you click on that, it will be pointing directly into the screen. And you can also put your compasses around that, and they will line up along the magnetic field. Or you could just kind of show the field. And if I pick alternating current, you can see you get an alternating current inside that wire. And we can also increase the current to get a larger field. So I'll remove alternating current field for a moment. That's our straight wire. With the straight wire, you can also show the motor effect just by bringing in a magnet. And, you move the north pole towards it, and it will exert an upwards force on that wire from its location. Or if you want to switch the current, the north pole will exert a downwards force. Likewise, you can make it a south pole and get those opposite forces. That's the motor effect. A couple other things you can show. You can show a ferromagnetic material with the domains pointed in random directions. And if you want to bring in a magnet, it will line up those domains along the magnetic field. And if you want to randomize them again, you can just hit the Zippo. If you put on field, you can see that when you turn off the Zippo and they align, you get a much larger magnetic field. Likewise, you can also use the, actually use that again. If we pull out the wire coil, this is another solenoid, but you can see it's kind of a chopped in half cross section. So we can, again, change the direction of the current or change the strength, or if you like, you can click on alternating current and it will alternate. Along with that, you can place your ferromagnetic core inside, and they will line up with the magnetic field caused by the solenoid. If you put on field and you hit the lighter, it will randomize the domains and maybe decrease the magnetic field a little bit. And if I click on fire again, you can see the green magnetic field will get stronger, perhaps not hundreds of times as it might in real life, but you can see the effect of a ferromagnetic core inside a solenoid. The last thing you can do, you can also show induction in generator mode. So in generator mode, it doesn't force a current in this coil, but you can create a coil by moving a magnet near it. And in this mode, you can add a frequency, and you can show the alternating current being generated inside the solenoid. And you can, of course, increase the frequency to get a larger current. So that is all the ways that I use this simulation. And in the absence of having actual equipment to play around with in your physics lab, I found that this was at least a decent second option, especially during the pandemic. So I hope you find it useful.